Before Rutherford, people believed in J.J. Thomson's plum pudding model of the atom, which proposed that the atom is a positively charged blob that is embedded with negative charges. Thomson's plum pudding model was like the Motorola Razr, an amazing discovery that everyone wanted at the time. Thomson's model held up for 10 years, just like Motorola's dominance of the chick phone market. But Rutherford's model ended up becoming like the iPhone, the newest, hottest, and best thing on the block. Rutherford and the experiment instead proposed that the positive charge is not uniformly distributed throughout the atom, but rather concentrated in the middle of the atom in a very, very small area. To prove this, Rutherford set up an experiment where he hammered a sheet of gold foil so there was only a few atoms thick. Hanging up this gold sheet and putting a detector behind it, Rutherford fired alpha particles at the gold foil. You won't need to know what an alpha particle is now, but we'll get to those in the future. All you need to know now is that an alpha particle is positive. Rutherford noticed that most of the time, the alpha particle passed right through the gold sheet and hit the detector, alerting Rutherford that it had passed right through. Because the positive alpha particle passed right through the gold foil, Rutherford was able to show that the plum pudding model of the atom was wrong. Because the plum pudding model stated that the atom was a positive blob, and multiple atoms together in a gold sheet would form a near seamless positive sheet, the positive alpha particle would bounce right off because two like charges repel each other. However, because it passed through, Rutherford proposed that the atom is mostly empty space. He noticed sometimes, about 1 in 1,000 tries, that the alpha particle would not pass through the gold sheet but instead ricochet back at the alpha particle gun either directly or at an angle. This happens when the alpha particle just happened to target the positive nucleus, causing repulsion to occur. You might ask, why didn't the negative electrons affect the travel path of the alpha particle? Because they are so small and move so fast around the nucleus that their effects on the alpha particle are basically negligible. Thus, Rutherford was able to show that the nucleus is not a positive blob as previously thought, but mostly empty space, with the positive nucleus concentrated in the middle of the atom and the negative electrons outside it.